Hello friends, welcome back to my channel. Today we'll discuss about superposition theorem. Superposition theorem is a very powerful theorem in electrical circuit analysis. It is used to simplify many complicated circuits. Okay, and the statement for superposition theorem is that the total current or voltage across a resistor or branch may be determined by summing the effects due to its independent sources. Right? If we have multiple sources, it may be a voltage source or current source in our circuit. So if we are to find some current across a resistor due to all the sources combined, what we can do is we can consider the sources one at a time, okay, while neglecting the other sources. Then after finding out all the responses due to individual sources, we can sum them up. And to better understand this concept, we need another concept known as short circuit and open circuit. Okay, so in order to nullify a voltage source, we should short circuit it. Okay, and if in our circuit we have a current source, in order to nullify that current source, we should open circuit it. Let us take one simple numerical example to understand this concept better. Suppose I have a 24 ohm resistor with a supply voltage of 20 volt, and I have also a current source here which is 2 ampere, and I have a load resistor, let's denote as RL. Suppose it is 16 ohm. Okay, now I want to determine the current IL, suppose in this branch or say load resistance, okay, due to 20 volt and 2 ampere current source. Superposition theorem can simplify this complex looking network. Okay, if you don't want to apply superposition theorem here, you can solve this problem using some advanced analysis techniques such as nodal analysis and all. But then if you use superposition theorem, it is easier to solve and it will take very less time. Let us see how to do it. Nullify the current source first. So what I said, to nullify the current source, I have to open circuit it. Alright. So the equivalent circuit after nullifying the current source will look like this. Open circuit. So what will be IL here? Let us say this is IL1. Okay, we have to find. So what is IL1? Apply Ohm's law. We remember that Ohm's law is I equal to V by R. Input voltage of 20 volt. Okay, and resistance 24 plus 16. Plug in your calculator, you will get around 0.5 ampere. So this IL1 is current due to 20 volt voltage source. Okay, now let's see what is IL load current due to the current source. So nullify the voltage source, and to nullify the voltage source we have to short circuit it. This is 24 ohm, and let us now consider the current source 16 ohm. Now let's assume the direction of current. Suppose this is IL2. Okay, apply current division rule. I hope you remember. Current division rule will be 24 ohm. Okay, 24 ohm plus 16 into total current 2 ampere. So this will be minus 1.20 ampere. The negative sign indicates that our assumed directions of current here should be opposite of this, means this load current should flow like this. All right, so we got IL1 and IL2, load current due to voltage source and current source. So apply superposition theorem. IL equal to load current due to voltage source plus load current due to current source, 0.5 ampere plus 1.2 ampere. This will come around 0.7 ampere. One important point we have to remember in case of superposition theorem is that superposition theorem does not apply to power. Okay, what is power? power equal to V into I. Okay, so you can verify this. So let's assume first, due to the voltage source, we had load current IL1 as 0.5 ampere. Okay, and our load resistance was 16 ohm. So what is power dissipation here in this case? Suppose, let's say this is P1, okay? IL1 into RL, 0.5 square into 16 ohm. It is around 4 watt. And we got, due to current source, we had a load current IL2 of negative of 1.2 ampere. Okay, so what is power dissipation in this case is that, let's say it is P2 IL2 square into RL. So we got, it comes around 23.04 watt. And after applying superposition theorem, we got IL as 0.7 ampere. All right, this is after applying superposition theorem. So IL equal to, we had 0.7 ampere. So let's say this is total power. Okay, it should be total power because this is after applying the superposition theorem. Response is due to voltage sources and current source. Okay, so let's P equal to L square into RL. 0.7, it comes around 7.84 watt. But we were expecting that summation of P1 and P2 should have been equal to P, right? But let's see what we get if we sum the power dissipations due to voltage source. P1 equal to 4 watt and P2 23 watt. Sum them up. P equal to P1 plus P2, 4 plus 23, 27 watt. So you can see that the actual power dissipation, which is 7.84 watt. Okay, so superposition theorem doesn't apply in power. Okay, please remember this. Thank you for watching.